Hello, this is Nishanth, roll number 22i378 from the Department of IT, second year. So this is the video for the RECode coding challenge. Now I'll be starting my presentation. The first problem that I have was to convert the word 1 into word 2 with the minimum number of operations that is possible. And the operation that I get to perform are to insert a character, delete a character and replace a character. Now let's see an example. Say we have to convert the word horse into ROS. So first we'd have to remove the letter R, and after removing it we'd be getting HOSE, and this is one operation that we have performed. And we'd have to next replace H with R and we get ROSE, and this is the second operation that we have performed, and we almost got the target word that we were looking for, ROS. And the final step that we need to do to get the word is to remove E. So the number of operation that we perform to get the word ROS is 3. So the edit distance in this case is 3. So I'll be taking another example for better understanding. So the next example that I'd be taking is to convert the word intention into execution. First, we'll be removing the letter T and it becomes INENTION. Now we want E. So we'll be replacing I with E. So it becomes ENENTION. Now we want X. So we'll replace this N with this X. So it becomes EXENTION. At this point we have performed 3 operation and we still want C. So we convert N into C. So we are going to replace N with C and it's becoming EXECTION. So at this point it's just the same as the execution string, except we'd have to add the letter U, and this is the fifth operation that we'll be performing, and we get execution as the final answer. So the edit distance in this case would be 5. So this is the algorithm part. What we are gonna basically do is to create a two-dimensional array with the dimension size is equal to m plus 1 and n plus 1, where m is the first word's length and n is the second word's length. We'll be initializing, populating the matrix, and we'll be finally returning the results. I'll be explaining it later on with examples for better understanding. Just keep in mind that we'll be returning the mth value of the distance array. That is the value that we are actually looking forward for. So we'll be following the idea of dynamic programming in this case. It's because horse, if you look at it, to be converted into ROS, we saw that it needed 3 operation. And what if I were to include another letter X, and why? How does the number of operation required change? In that case, it's actually 3 plus 1. So how did I arrive at this value? It's because horse to be converted into ROS required 3 operation. It's just one letter that has to be changed from this point. So it is 3 plus 1, that is equal to 4. So we are basically using the subprogram's results in order to solve a larger program, which is a concept of dynamic programming. So this is the matrix that we'll be creating. We'd have to convert A, B, C, D, E, F into A, Z, C, D, E. So this is the empty string that we'll be taking, and we'd have to fill the row with the value of the first word, and the second the column we'd have to fill with the letters of the second word. So now I'll explain what this boxes actually mean. So this box is gonna imply the number of operation that is required to convert the word ABC into A, and this box is gonna imply the number of operation that is required to convert the word ABCDEF into AZCDE. So that is basically the answer that we are looking forward for. So this is the conversion. Now I'll explain how I got this. This is an empty string. We'd have to get this empty string. In order to get an empty string, there's no real operation that we need to perform. And if the word that was given to us was A, and in order to convert it into a null empty string, we'd have to actually delete A. That is one operation that we had performed here. If the word that was given to us was AB, then we'd have to delete A and we'd have to delete B, which is 2 operation. We'd have to do the same for the C as well. So it's the same value for the values in the rows. So for column, what we have to do? We have been given the empty string, and in order to get A, we have to insert A. So the number of operation is 1. If we want Z, we have to first insert A, that is one operation, and we have to insert Z later on. So the number of operation is 2. So likewise, fill the value of the column as well. If you look closely, it actually follows the specific pattern with their values equal to the ith value, like 1, 2, 3, 4, 5, 6 is based on the index, and this is the jth value. So this is what I have actually talked about in the algorithm part. Here we'll be initializing the I0th position with the value of I and 0th j position with the value of j, and this is going to be for the length 0 to m and 0 to n that we had done. We'd have to similarly fill all these values, and I'll explain one more for better understanding. So what this value actually indicates is the number of operation to convert the word AB to A. So if you look at it, we'd have to just delete B in order to get A. So the number of operation here is 1. Here we've been converting all the words into just a word with single character, but the problem actually comes when we have to convert this into a word with more than just 2 letters. I'll explain it to you. So this is the part that I was talking about. In order to convert AB into AZ with more than just one letter, that's where the actual confusion comes. If it's a big word, we just cannot be guessing it, right? So what we have to do is we have to look into the value of these three. That is the leftmost value, topmost value, and the top left value, and we have to choose such a value that gives the minimum among them. Say if you're gonna take this value, the top value, what it means that AB, in order to give A, it takes one operation. AB to give A, it takes one operation. So we actually want AB gives AZ. So AB gives AZ. AB to A takes one operation. And if we want another Z, we'd have to insert Z. So that is 1 plus 1, another operation, that is 2. So from this point to this point, we need two operations. So we can reach this point from this point as well and this point as well. So we'll be taking those into consideration as well. Now we'll be taking the leftmost value. So what it means that in order to convert A into AZ, the number of operations it's going to be requiring is 1. For A to become AZ, it's going to take one conversion. The string that we had been given is AB. To become AZ, A to AZ requires 1. So AB to AZ, actually we have to remove this B on top. So it's gonna be 1 plus 1, which is 2 again. So this one and this one are actually giving 2 for this box. So we'd have to approach it from this point to check which is the minimum among them. So this box implies that in order to get A, we'd have to perform 0 operation. A to A requires 0 operation, but the given string is AB, and we'd have to get AZ. So we'd have to AB to AZ. So we'd have to replace B with Z. So it's 0 plus 1. So we'd be filling this box with the value of 1, as we did. So this box implies that in order to convert AB into AZ, the number of operation that we'll be needing is 1. If you look closely, it follows a pattern 0, 1, 1. The minimum among them is 0. So it's actually the minimum value plus 1. This is the pattern that it's going to actually be following. So let's take another example to see if it works. So this is an example. Here the minimum value is 1. So 1 plus 1, it's 2. It's actually the value that we have filled here. So we'd be following the same thing for the other boxes as well, except when there is same characters, like in this case C and C. So what do we do in those cases to find the value of this box? So what we do is we take this point, the top left box. What it means that in order to convert AB into AZ, we need one operation. AB to AZ requires one operation. This is the box where ABC to be converted into ABZ. What is the number of operation that is to be done? That is what we'd have to find. ABC and AZC. It looks quite similar except there is an additional C here. AB to AZ requires 1. So it's just C that we want. So there's no insertion needed or deletion or replacement needed. It's just C and it's there. So we'd be copying the topmost left value, and this is what we get. So we'd be following the same for the remaining values of the table, and we fill this table. And mnth value, this is the value that we are actually looking for. This box means that in order to convert the a b c d e f into a z c d e, we need two operation, and this is the final answer that we are looking for. So this is the coding part. We'll be creating a two-dimensional matrix with the length m plus 1 and n plus 1, as I told you. And this is the part where we fill I and j, cos dp of I0 and cos dp of 0j is equal to j. This is for the initial values that I had explained. And we have to first locate the, see whether if it's the same character, and if it's the same character, as in this case a and a, what we'd have to do is find the top left value, and we have to write the same value over here. So this is what it does. So if there's a different value, if it's not the same character, then we'd have to find the minimum of the all the three neighbors, that is the top left and the top value. We'd have to find the minimum among them, and we'd have to add 1 to it, and we'd have to write the value in that box. And finally we'll be returning the mnth value of the array in order to get a final result. And the time complexity of this program is O of m into n, as we'd have to visit each cell in order to get the mnth value. So it has passed all the test cases in the examly portal. And for the example that I had explained with, it works perfectly, and this is the output. It works fine. And this is the custom input test case that I have given. So moving on to the next problem, it's actually a simple deletion problem, except there is quite some difference. A normal deletion of the linked list, what we do is we delete it from first. Here we'd have to delete the nth node from the linked list from the last. So the only tricky part here is to actually find the node that we want to delete from the last. So if this was the linked list we are given 1, 2, 3, 4 and 5, and if n is equal to 2, that is the value from the last that has to be deleted. So 1, 2, fourth value has to be deleted. So after deletion it has to become 1, 2, 3, 5. So this is what we are going to be solving. And so the algorithm for this question is, first we try to find the length and store it in the variable L. This is done through using temp and traversing till the last node, and we find the length, and we'd have to find L minus n in order to locate the node where we'd have to perform the delete operation. And if L minus n comes to 0, it means that it's the head node, and we'd have to update the head pointer, or else we'd have to find the node and we'd have to make modification to it. I'll be explaining it later. So let's take another example. If the linked list was 4, 8, 15, 16, 23, 12, 7 and 5, if we were to delete the third node from the last, it should give a linked list without this value. We check with the custom test case if our program works for it. So we'd have to handle exceptional cases as well. If there was to only one element in the linked list and we had to delete that, it should return a empty list. We'll handle those cases as well. So first we'll be finding the length here. So we'll be using the variable L is equal to 1. Temp is actually pointing to head. As we know, for finding the length we'd have to traverse it till the last node, till the value becomes null. That is temp dot next equal to null. Simultaneously we'll be updating the value of L and making the temp point to the next value in the linked list. So this is the linked list that we are going to be taking, and its length is 5. If suppose we were to delete the fifth value, that is 1, 2, 3, 4, 5, it turns out to be the head. What do we do in those cases? That is, if L minus n equal to 0, we increment the head. Head is equal to head dot next, and we return the head. But what if it's a other node other than the head? Say for example n is equal to 2, then we'd have to delete this node. In order to delete this node, we'd have to actually make the temp point to this node. For that, we'll be making use of this while loop. It's gonna iterate till c, that is 1 is less than n minus 1, and it's gonna make you point to this location. The reason why we want the value to be over there is we will be actually giving a direct connection from this node to this node, basically deleting this one. So what we are going to be giving is temp dot next equal to temp dot next dot next. So this 200's next, that is it was 300, we are going to make it as 400, so it's going to actually skip this node, and this node actually gets deleted. The time complexity for this is O of n. So it has passed all the cases in the exambly platform, and for the example that I told you, let's check if it works perfectly. So I've given the custom input, and it's the link that we have linked list that we have discussed about, and it works just fine. So we have solved the two problems. So I'll be concluding my presentation. Thank you.